when we design anything, we're looking always for precedents of those who have gone before us and have done work that may be appropriate or may advise us in some way. Some of the precedents that we've been looking into are presented here. The first one is Earthships. This is a group of people who have put together a type of technology that's completely recycled materials. Many of the homes are passive solar and earth burned, as shown here in this picture. Here's one outside of Taos, and this short video tells a little bit about the process of building an Earthship.
Imagine living in a home that cost you nothing to heat or cool. Imagine building this home yourself. Imagine growing your own vegetables year-round in this home. Imagine no utility bills. Imagine easily available, limitless natural resources to build this type of home. Imagine a more earth-friendly civilization. Imagine Earthships. Earthships demonstrate a way to live in harmony with the planet by encountering natural resources without depleting them. An Earthship is a passive solar home made out of natural and recycled materials. It is off-grid, getting its power from the sun and wind, its water from the rain and snow, and it reuses, contains, and treats its own wastewater with a combination of wetlands and hydroponics. We call the compilation of all these integrated systems biotecture. The major building component of an Earthship is used automobile tires filled and compacted with earth to form a rammed earth brick encased in steel-belted rubber. These bricks and the resulting load-bearing walls are virtually indestructible. The 3-foot thick massive walls and the method of incorporating them into the earth create living spaces with a thermal dynamic that results in a stable room temperature. Recycled cans and bottles are used as filler when packing out tire walls. They are also used like little bricks to form interior non-structural walls. A matrix of cement is formed, which is the strength of these walls. The cans and bottles serve no structural or insulating purpose. They simply are a method of forming concrete into walls in a low-tech way, using recycled materials instead of more cement and wood. The thermal mass construction of the tire walls works with passive solar gain to create a warm living environment even on a freezing day. A stable mass temperature of 58 degrees trapped in the walls and needs a little solar gain to temper up to 70 degrees or whatever your comfort zone is. The lower winter sun shoots deep into the house, charging the dense, massive walls and dense floors, which in turn release that warmth back into the room when the air temperature of the room starts to drop. Alternately, summer sun does not enter farther than the planter itself. In addition to the thermal cooling properties of these earth homes, passive ventilation systems assist in maintaining a comfortable temperature. Dormer and hopper windows, skylights, and doors can be opened to allow the natural convection of fresh air. Insulated shades against the glass face keep out the hot summer sun, as well as to keep the heat inside on cold winter evenings. For extremely hot climates, a cooling tube can be added. In this case, the incoming air is channeled through a tube and buried 8 feet in the earth, tapping into the cool earth temperature and drawing cooled air into the house. There's a limited amount of fresh water on the planet. In order to conserve and protect this precious resource, we have developed unique catchwater, graywater, and blackwater systems that work together to extend the use of a given amount of water. Earthships efficiently use fresh water by using it 4 times. Rain and snow is caught on the roof and funneled into a cistern. This fresh water is prepared by the water organizing model. This unit consists of a panel of filters and a DC pump which pushes the water into a conventional pressure tank. As water is needed, it is filtered, pumped, and pressurized for household use. Water that drains from the sinks in the shower passes through a grease and particle filter, then on into a graywater treatment planter where plants flourish from the water. This interior water treatment cell is potentially a food producer, a source of beautiful and fragrant flora, and an oxygen producer, in addition to functioning as a cleaner for the gray water. The extra water not used by the plants drops into a reservoir at the far end of the planter where a pump sends the cleaned gray water to fill the toilet tank for flushing. Used toilet water, known as black water, is flushed outside for treatment in a conventional septic tank. The The septic tank we use is solar heated and glazed with south-facing window, which enhances the anaerobic breakdown process. The unit functions like a regular septic tank with a line out to a conventional leach field and an alternative series of rubber-lined planter cells which feed the exterior landscaping while further cleansing the water. Hot water is obtained from self-contained solar water heaters with gas on-demand water heaters as a backup. The solar hot water is usually mounted onto the systems area and built into the shape of the building. The systems are packed into a room containing all of the equipment needed to run an earthship except for the cistern, which ideally lies very close to this area. We call this area a systems package. The water organizing module, pressure tank, gray water pump panel, batteries, and the power organizing module are all kept in this small room called the systems package. An earthship's power is generated by the sun and wind. Solar panels and windmills collect energy which is sent to and stored in a bank of batteries located on top of the system.
So that's a brief presentation of earthships. Earthships have some problems that we need to be addressed. The first foremost is given the rocky soil of the mountain, whether building into the mountain is possible. There may be some places where this is could be accommodated on the side of an existing slope. Second issue that we have to deal with is building codes. This is a technology that doesn't conform generally with the expected building technology of a home in some ways, and the local building department would need to be on board with the use of this type of technology. We've discussed the Lead for Home project in our portfolio, and I don't think we need to go too much more into that, other than to say that it's a great protocol for getting more conventionally built homes into the realm of sustainability. William MacDonald is a internationally known architect who has recently published a book called Cradle to Cradle, which talks about the life cycle of all the products that go into homes and how to be efficient and energy sensitive in the use of these materials and recycling materials. And his work may advise our construction process as well. Tiny homes and tiny homes on wheels. This is a type of construction that really says how much space do we really need to live in, especially if we have shared community space and also a vast amount of open area that we want to preserve. These homes could be, if built off-site, could be trucked on their own wheels to the site, therefore not creating a lot of noise and impact environmentally on the mountain itself. And there's some examples of some kind of contemporary looking prototypes. Also more traditional cottagey forms are a possibility, and the sizes of these units could be varied, and also they could be combined into small groupings depending on what we feel is appropriate for the site. Co-housing prototypes. The co-housing model is a model of living together in shared space, primarily in small living spaces with collectively shared common space that everyone uses, a large meeting room, a dining room, kitchen. Although each home is has its own small kitchenette, it reduces the amount of area that you actually live in personally by extending your living space into a community shared space. So this model may be something appropriate to our work on the mountain, as we have such a strong emphasis on community. The nice thing about these types of projects is that they can be built at various densities, keeping the land needed for multiple housing to a minimum, keeping the natural and sacred spaces protected from intrusion on the mountain. Here's a small village of homes with a common central home that's shared. That is also a type of prototype of a cluster home, keeping the natural land protected. The monastic prototype is something that I'm personally interested in. I did my architectural thesis on a retreat center based on a monastic prototype, and it's a little bit of an abstraction, but the idea basically is that the individual, what were called cells for the monks, could be small tiny homes together on a cloistered space, probably without the cathedral in the middle, with common spaces for officing and kitchens and shared resources, each unit looking out to the natural world on the outside, but joining together in community on the inside. Many of these monastic monasteries were built during the medieval days, and in my studies in Europe, and travels in Europe, I've had the opportunity to take in a lot of them and understand some of the things that are important about them. When living in community, not only is the architecture important, but what has been called the rule of the monastery, or the rules that we all agree to live by, things like sharing of resources and private versus collective space, all need to be considered to make for a successful co-housing type formation. This is actually a print of my thesis done some 30 years ago. We have collective spaces and a kitchen. This is an addition to a church on Lake Huron in northern Michigan, and it has a shared community outdoor space, a library, offices for the staff, a kitchen, a meeting hall, and then this is a view of a sketch of the cloister space looking out towards the lake, closed on 3 sides but open to nature on the 4th. Model of the project, and that's pretty much it for prototypes at this point. We're of course very interested in the community's input for